Okay, so I'm not going to analyze this circuit because it's fairly involved, but it can be done. Okay, so here are two op-amps, V1 and V2. Okay, so now we feed back the positive of this op-amp and the negative of the other one. Okay, so this is fed into another op-amp. And then we have feedback. And then there is a resistor. Okay, so negative, positive, call this R1, R2, R2, R3, R3, R4, and this last one is actually a potentiometer. It is a potentiometer. A potentiometer is a variable resistor, so you can change the resistance by turning the knob. You might have seen this in your kit. Okay. Okay, so if you want to analyze this, you start doing the same thing that I did, which is you will assume a bunch of currents, and you will essentially relate the different currents to the voltages and resistances, and then eliminate what you don't care about. Let's put this as V3 and V4. Okay, the trick is to first find a relation between V out and V3, V4, and then you can relate V3, V4 with V1, V2, and that's how this proceeds. So V out equals R4 divided by R3, 1 plus, what, let me just find the expression for it. Let me just write this down. This is, so first step is to figure out an expression for V out is a function of V3 plus V4. Okay, and then V3 and V3 and V4 can be related to V1, V2. Now, if you, so this is just one of the equations comes out, and since there are some other equations which I'll not write. The key thing here is that R5 is a potentiometer, and you need to basically turn the knob such that R5 equals R4. And if R5 equals R4, then under this condition, V out equals R4 divided by R3, 1 plus 2, sorry, 2 R2. Divided by R1. Then V2 minus V1. Okay, so this is saying that the output voltage is the sum ratio of, well, sum is proportional to V2 minus V1, and that's what we were after. And that's only true if this is true. Okay, now you might say, how is this even different from a difference amplifier? You still have to match. One good thing is that you only have to match one resistor, not two. But then that resistor, which is R5, you actually have a potentiometer. So you have the flexibility to change the resistance by just turning a knob. So what you'll do is you'll first put V1 and V2 the same. You'll know the inputs. You'll tune R5 such that R5 equals R4, and then you can use this circuit for anything. So that process of tuning the R5 such that equals to R4 when V1 equals V2 is called a calibration step. Once you calibrate this device, it'll start working as intended. Now, if there is change in temperature, then this clearly is not going to work that well because now the resistance is changed. But as long as you are calibrating it again, you should be good. So, you need to probably periodically check the circuit to see that R5 is actually balanced with R4. So the advantages are over the difference amp is twofold. One is only one resistor to be matched. And the second one is that R5 uses a potentiometer, which can help you to match the resistor. So that's the instrumentation amplifier, and that's the one which you would use if you are trying to use an amplifier for computing the difference. Okay, let's do two more circuits, and then we're done with circuits, Opamp circuits.